Yeah, thank you for coming, everyone. My name is Steffen Görtz. I work on connected embedded devices at a German engineering service company called sevenlab Engineering. And today I will be talking about MQTT-SN. But before I go there, a small recap about MQTT. Maybe just one question. Who has worked with MQTT before? Okay, I could have skipped that. And who have worked with MQTT-SN? Ah, okay. So, completely redundant. Yeah, short recap, what is MQTT? MQTT is a messaging protocol widely used in the IoT sector and other things, where the core concept is that sources and things of data or messages are separated from each other by a broker. Yeah, the information is organized in a hierarchy of that is called a topic. And the broker basically has the task to filter and route the messages to the right thing. And the clients are so totally separated and don't directly talk to each other. It's designed by IBM in the 1990s, and it's simple and efficient. It's built on TCP/IP, which will be important later. And yeah, it's probably one of the most important protocols in using for connecting IoT devices, aside from HTTP. If you look at the general population of devices. How that looks normally is that you have like this topic entity is a long string. For example, you have like a protocol version and then something like a device ID that identifies a certain device, or maybe even a certain hierarchy of data in your room or sensor, and yeah, then you push your data there. So if you have MQTT, why would we like to have MQTT-SN? Yeah, the motivation was to bring like this publish and subscribe data concept to battery-powered wireless sensor networks, and they are specifically to nodes that are so constrained that, or for other reasons, they don't have a IP or TCP networking stack. Specifically, there was a use case for Zigbee-based devices in a research project at the IBM Research Labs in Zurich. And yeah, the results of that were then later MQTT-S or MQTT-SN. The requirements were that it should integrate well into the existing MQTT infrastructure. It should be transport agnostic. So yeah, and it should be really constrained device friendly. So it should be low on energy usage. It should be low on data rate usage. It should be low on bandwidth utilization. And like a specific use case for this wireless sensor networks, where as well that it could be that the network needs to reconfigure while it's working. And so there should be some way of service discovery implemented as well. So what you would maybe do with DNS for MQTT, it should be actually supported directly from the protocol. Yeah, the result was MQTT-S first in this paper published, and it was renamed to MQTT-SN for obvious reasons. Yeah, what are the differences between the two protocols? As I said before, it should be transport agnostic. TCP/IP was the biggest problem, but also as it should integrate well, there is no MQTT-SN gateway. So it's only the clients that differ and not there's no MQTT-SN broker, only the clients differ, not the rest of the infrastructure. And as there is no MQTT-SN broker, there's a component introduced that's called the gateway that basically bridges between the two worlds and translates between the MQTT-SN messages and the MQTT messages. These gateways, a method exists to discover them. So there's some kind of broadcast and advertisement mechanism. So that basically service discovery is possible in this kind of networks. To save bandwidth, I showed the long topics before. There was a mechanism introduced to alias topics so that you can basically say, I want to have a stand-in, like a short ID or a short like alphanumeric string that I can use instead of long topics. And it can be either assigned at runtime or predefined on both sides, so client and server. Yeah, that was that. And then in MQTT, like in regular MQTT, you first do the establishment of the TCP connection. Then on top, you establish a connection in MQTT as well. And yeah, that's a lot of messages and takes a lot of bandwidth and time. So it was also there was also one mechanism introduced to publish messages to an MQTT broker without connecting first. And last but not least, and very important actually, MQTT-SN provides a way to support intermittently connected devices or sleepy devices. So like as a battery powered sensor node, I want to maybe establish a connection to the MQTT broker and then go to sleep and wake up and not reestablish the connection. And biggest problem is actually that MQTT assumes that as a consumer or a subscriber, I'm there when a message arrives and there's no queuing when I'm not there. And this is basically solved by the gateway, which then acts as a stand-in for the device and sends the queued messages later. Yeah, that was basically it. So this is MQTT-SN. Some things to consider. It's basically a direct. You can establish a direct connection with any MQTT broker, but in like the MQTT-SN message layout or implementation protocol layout, the maximum message size already is only 2 byte length field, compared to the 265 megabytes that is supported according to MQTT. And that is the maximum, like the actual, what is actually available depends on your transport. And as you don't have any more transport guarantees from TCP, so you don't, on an IP, you don't have segmentation, fragmentation, you don't have reassembly, you cannot, your MTU in the link is usually very small and much smaller than what you see on a normal IP network. Yeah, it's a bit non-obvious because of these aliasing of topics. If you do register for a topic with a wildcard or subscribe to a topic with a wildcard, then the gateway translates that all possible topics and maps them to one like alias each and all sends them down to the device. And as you don't know how big the structure and hierarchy is, that could just mean that the broker sends so many topic aliases that you run out of memory, I heard. And then made for sleepy devices, the sleep duration is only up to 18 hours. So if you want to do something like doing an MBIoT device with that and only wake up once a day, that will not work. Yeah, no security reliability guarantees whatsoever, because I mean what TCP delivered already is out of scope because it's now transport agnostic, and the majority of the specification there are 2 versions or 3 versions, and then it was untouched for the last 13 years, I think, 12 years. There are still people working on like MQTT-SN version 2.0, but it's somewhere coming. Yeah, how does the MQTT-SN support in Zephyr look like? There's a fully implemented transport-agnostic MQTT-SN client library implementation, and there's also one UDP-IP reference implementation provided. There's also one example. Timeline is, yeah, basically it was provided or contributed in 2022, and then there were 2 additions for like the wildcard support. That's something that I mentioned before, and then also support for the gateway discovery routine. What is not supported is the predefined topic, so that you establish it on both sides before you run, or not at runtime, and that you can publish messages before connecting or without connecting to the MQTT broker, which is probably a really nice feature to have. Yeah, change in last will testaments is not really important, I think. You might ask, you know, where do I have use for that? One use case is, for example, if you have like an open thread, you want to do like an open thread node, and you will find out doing a MQTT handshake or a MQTT-S handshake is really, really painful, and MQTT-SN is basically a solution for that. No comparison with co-op because of time. 2 real-world examples of people using the MQTT-SN implementation on Zephyr in the real world, and one of them is a cat tracker. And if you have implemented MQTT-SN project or plan that, please talk to me. I would like to have a chat. That's it.